Hello everyone, I'm Namrata, a PhD student at IIT ISM Dhanbad. So today's problem solving session week 11 for the course differential equation for engineering, in which we will solve the problem related to week 11 session, in which we already studied the heat equation. Am I audible?
Yes, madam.
Okay. So these are the questions we will discuss in this session. The question one is solve the boundary value problem associated to heat distribution in a finite bar with insulated ends as given by. This is heat equation with finite bar, that means x is finite, 0 to L given, and ends are insulated. Insulated ends are given. How to solve these type of problems? Okay, we will discuss how to solve this problem. So the question one is heat equation with finite bar with insulated end. We are going to solve question number one. Please try to solve. Okay, question one is solve the boundary value problem associated to heat distribution in a finite bar with insulated ends as given by qt minus c square uxx is equals to 0, where x is from 0 to L and t greater than 0. With initial condition e की power minus x and boundary condition. This is Newman type boundary condition because derivative is there. Now how to solve this problem? We will use variable separable method to solve this problem. So for variable separable, we have to suppose uxt is of the form. Now what we have to do? We have to do we have to solve for x and for t, then we can find ux of t. So we can write by given heat equation, we can write t dash upon c square Let us suppose this is equal to lambda, a constant. Fine. Can we write from the given heat equation? Can we write it as T dash upon C? You can partial differentiate uxt with respect to T and with respect to X, double derivative, and you can put, then you will get this expression. Fine. Okay, from this expression, firstly we will focus for X. By using boundary condition, what is boundary condition? U x 0 comma t 0 and u x l comma t 0. Okay, by using this boundary condition, we will get x dash 0 and x dash l, because uxt is into tt. When you put after differentiating with respect to s, you will get this. Again you will put l, you will get second boundary condition. Fine. So this is SL problem. We have already done many times the SL problem. Regular, hence we have to find the solution for lambda. Let's say for lambda is equals to 0. We have three cases: lambda 0, lambda less than 0, lambda greater than 0. Firstly we will focus for lambda equal to 0. When you put here the lambda equal to 0, you will get x double dash x is equals to 0. From here the solution for x will be c1x plus c2. Fine. After applying boundary condition, after applying boundary condition, first one, then you will get c1 0, sorry c2 0, no c1 dash, because x dash will be c1. Okay, then you will get c1 0. After applying again this will 0, that imply x of x is c2. Fine. Zero c1, again here c1 is 0, not c2 0, so x of x will be c2. That means we get a eigenvalue here for lambda 0 is eigenvalue with eigenvector associated with c2. C2 is some constant. We can say it is 1, 2, anyone you can choose. So we can write lambda is equals to 0 is an eigenvalue with eigenvector C1, let's say 1 constant. Okay. Now for the case lambda when greater than 0, let's say mu square, then you will put here, sorry, this is minus, what you will get from here, the solution for x, c1 e to power mu of x plus c2 e to power minus mu of x. Fine. Now we have to apply the boundary condition. First one is x dash 0 is equals to 0. When you put, let's say firstly calculate x dash. What will be the x dash? Mu c1 e to power mu of x minus c2 e to power mu of x. Fine. Now x dash 0 is equals to 0. That implies c1 minus c2. That is c1 is equals to c2. When you apply, then you will get, if you put c1 is equals to c2 and take it outside, and convert it into sine, because sine hyperbolic of L, okay, let's firstly put mu L minus e to power minus mu L. Okay, what will be the value of this expression? Can we write it as sine hyperbolic mu of L? Okay, from here, because this could not be 0, so C1 will be 0. Fine. And C1 is equals to C2, that implies C2 is also 0. So in this case, lambda cannot be the eigenvalue because we get the trivial one. Okay. So we can write we get trivial one, so lambda is equals to mu square is not an eigenvalue. Now for the case minus mu square, when mu is not equals to 0, of course, then if we put minus minus plus mu square x of x is equals to 0. From here you will get the solution of the form c1 cos mu of x plus c2 sin mu of x. Fine. Now what we have to do, we will apply the boundary condition again and find the value of c1 c2. What is x dash? Firstly calculate x dash. Minus sin mu of x mu cos of mu of x. Okay. Now first one is x dash 0 is equals to 0. That implies this will vanish. So c2 is 0 from here. Okay. After applying second one, you will get c1 mu L is equals to 0. That implies c1 also 0. But we have to find the non-trivial solution. For non-trivial, let c1 not equals to 0. That implies sine of mu of L is equals to 0. From here, mu of L will be n pi. Okay, where n is from 0, 1, 2 and so on. Okay. So what will be the value of mu? N pi upon L. So lambda will be minus n pi upon L whole square. This is eigenvalue. And n is from 0, 1, 2 and so on. What will be the eigenfunction? The eigenfunction will be, because C2 is 0, so C1 cos mu of x. C1, let's say 1 and cos mu. Mu is, sorry, yes, lambda is n pi upon Lx. Okay, this is eigenfunction. Now, for this eigenvalue, we have to solve for Tn also. The general solution for at the place of lambda, we can write minus n pi upon L whole square c square Tn of t is equals to 0, where t is greater than 0, n is 0, 1, 2 and so on. Okay. Now, from here you will solve and you will find the value of Tn. Okay. This will be Tn. So we can write u of xt. Let u of xt is equals to, by the principle of superposition, n is from 0 to infinity. What is Tn? Tn is an e to the power minus n pi c upon L whole square into t into xn is cos of n pi by L into x. Okay. Now we have to satisfy the boundary condition and then we can find the value of an. Fine. Okay. Let's use the boundary condition. What are the boundary condition? Sorry, boundary condition we have already used. We have to satisfy initial condition. The initial condition, what is initial condition? Ux comma 0 is e to the power minus x, where x is from 0 to L. By using this in the previous solution, we will get cos n pi by L into x is equals to e to the power minus x. Okay. After putting t is equals to 0, we will get this. So what will be the value of an, which is Fourier constant, upon where n is from. Okay. We will calculate n is equals for n is equals to 0 separately. So the integration for denominator will be 2 by L by 2. So we can write it, and for numerator formula we can use a upon a square plus b square e power minus e power ax cos bx. Uh, Formula something like this we can use for numerator. And after putting upper limit you will get minus L cos of n pi plus 1. You can check the integration. This is the integration. L will cancel out, 2L will be left, and this will become 1 minus cos n pi minus 1 ki power n and e ki power minus L. So this will be the value for an, where n from 1 to and so on. What will be the value of a naught? When you put 0, you will get 1 by L, 1 minus e ki power minus L. So I am writing it separately. Fine. So the required solution, sorry, this is a naught. What will be the required solution? Okay, slow. So I'm just calculating the coefficient of an here by using the initial condition. Okay, the initial condition given is ux comma 0 is e ki power minus x. I am putting in the solution so that we can calculate the value of an. Okay, for calculating the value of an we will use Fourier constant and we solve this integration. You can check the integration. For denominator the integration will be L by 2, and for numerator I am using the formula e power ax into cos bx integration of, then we will get this expression for n is equals to 1, 2 and so on. And for n is equals to 0, the value will be, because 0 is cannot be written in the general form, if we put n is equals to 0 here, then you will get the an value for n is equals to 0 different from this general value. So I'm writing it separately. You can write in an also. So the required solution will become for a naught and for n is equals to 1 to infinity, this is 2L upon L square. An, the value of an I'm writing 1 minus e ki power minus L into cos of n pi by Lx into e ki power n pi c by L whole square into t, where t is greater than equals to 0. Fine. So this is the required solution. If there is any doubt, you can ask in this question. Is it clear? Question number 1.
Okay, man.
Okay. Let's move to the next question. Question number 2. Okay. Let's use for the question the black color. Question number 2. The question says, okay, I'm writing the question first of all. Find the temperature in a what what is the question? Sorry. Find the temperature in a laterally insulated copper bar of 80 centimeter long if the initial temperature is 100 into sine pi x 18 degrees Celsius and the ends are kept at 0 degrees Celsius. Okay. So firstly we have to model this uh, given problem into heat equation. Okay. So how we can write? Sorry. Okay. Let me write the question first. In a laterally insulated copper bar of 80 centimeters. So L is given. Okay. If the initial condition and the ends means boundary condition and the ends are kept at 0 degrees Celsius. Okay. Now please write the heat equation with initial condition and boundary condition and tell me the expression. The question is how long will it take for the maximum temperature in the bar to drop 50 degrees Celsius. And one more thing is given, diffusive constant for copper 1.15. Okay, so this is the question. How to model the given problem? First of all, we have to write the equation. Okay, can anyone tell me the given problem in the form of heat equation and with initial condition and boundary condition? Okay, I'm writing. So the diffusive coefficient constant for copper is given 1.15. C is, so it is C square. Okay, fine. and the value of x is given from 0 to 80. L is 80 centimeter. What is initial condition? Initial condition means when temperature is 0. The given initial condition is 100 into sine pi x upon 80 degree. Okay, you can, no need to write here. What are the boundary condition? 0, because the question the boundary condition is given as the ends are kept at 0 degree. Okay, that means the ends are from 0 to 80, they are kept at 0. Uxt is temperature distribution can we say uxt is temperature distribution at x and at time t. Okay, so again we will start with variable separable method, setup for SL problem for the variable x, and by supervision we can principle of supervision uh, you can obtain the uxt solution. So I'm skipping this part because we have already done in the previous question, just the difference in boundary condition. So in the previous one there was cos in the solution, so in this case there will be sine. You can check because we have already done this thing many times. So I'm writing again, start with variable separable, set SL system or problem for variable x. I'm just telling the step. Using eigenvalue, find solution for t, and by superposition, principle of superposition, we obtain the solution. Okay, so you can check these steps, then you will find the solution of the form n by x upon L. L is 80. Okay, e की power n pi L whole square. L is 80 whole square into c square means alpha square. Alpha square is 1.15. Okay, so let's take it. Alpha square where alpha is 1.15. Fine. Is there any doubt till now? Is there any doubt in problem formulation, and is there any doubt in solution? You can ask. Now what we have to do, we can use initial condition and we can find the value of an. Fine. First of all, we have to find the value of an. Yes.
Ma'am, in the formulation,
Yes.
you write UT minus 1.15 UXX equals
Yes.
here alpha 1.5 or alpha square equals 1.
Alpha square. This is diffusive constant is alpha square. Diffusive constant is alpha square. Okay.
Okay, so
Is there any other doubt?
then ma'am you write alpha equals 1.1 in the last line.
Okay, okay. Sorry, this is alpha, not alpha square. Sorry. No, this is alpha square. Diffusive coefficient, whatever you can take, c or c square, alpha or alpha, because it is a constant value and you have given 1.15. So you can give it alpha or just alpha square. This is just symbol. Okay.
Okay.
Okay. Now we have to find the value of an by using the initial conditions. Now by initial condition, what was initial condition? 100 into sine nx upon 80. Okay. After putting t is equals to 0, you will get left hand side. Now from here you can see this is pi, not n. Okay. If you put n is equals to 1, then you will get both right hand side and left hand side will be equal. So what will be the value of a1? 100. Can we write? Comparing both sides. When n is equals to 1, then both sides will be equal. So we can write a1 is equals to 100 and an is equals to 0 for all n greater than equals to 2. Fine. Or you can calculate an with the help of Fourier coefficient also with the formula of integration. So what will be the solution? a1 sine pi x upon 80 into e की power 1 pi square alpha square upon 80 square into t. Okay, you can check pi square into 1.15 into 80 square. The value for this will be you can check the calculation. So we can write okay. Now the question says How long will it take for the maximum temperature in the bar to drop 50 degrees? So we have to calculate T time. Okay. When temperature distribution becomes 50 degree. For second part. 50 degree sine pi x upon 80 into so can we write the approximate value of sine pi x upon 80? If sine pi x upon 80 approximately equal to 1, then fifty is equals to 100 into 1 into e की power minus 1.77 into t. Okay, so this will 1 by 2. So t will be, if we take log negative sign will be there, and this negative will cancel out, and after calculating this you will get the answer. Unit or second you can write. So this is the answer. Is there any doubt? So we can write therefore temperature drops 50 degrees Celsius at some point after 388 seconds. Okay, is it clear? Okay, so let's move to the next question. Question number 3. Question says, suppose a thin box has temperature U1 at x is equals to 0 and U2 at x is equals to L. No need to write initially in the question, you can cancel the initially. Okay, in the box after long time. Okay, so we can represent the given problem. The given problem can be represented as is equals to 0. Sorry, this is L. Okay, u1 given, and at x is equals to L, it is given u2. So can you see it is not homogeneous boundary condition, because at the boundary there is u1 and u2. So in order to solve this type of boundary value problem, firstly we will convert it homogeneous problem. So can we write the unknown ux comma t as some v of x comma t and g of x, such that v of x comma t satisfy the boundary value problem for vx comma t okay. So we have assumed uxt is of the form v of xt plus g of x. You will calculate v of t, v of xx, you will put in this expression above equation, then you will get, and with boundary condition you will get after putting this expression for vt, vxx, and for boundary condition you will get this. So from here, what will be the value for g of x? G of x will be c1x plus c2. After applying boundary condition, the value of c1, c2 you can calculate. C1 will be u2 minus u1 upon L into x plus C2 will be U1. Okay. C2 will be U1 and C1 you can calculate U2 minus U1 upon L. Okay. So after calculating G of X, let's say this is equation 2 and this is equation 1. By solving the boundary value problem 2, we can obtain the required solution v of x comma t. What will be the solution? An sine n pi, this is n pi x upon L into e की power minus n pi upon L whole square alpha square into t. Okay. Now for uxt, ultimately we have to find the solution of u of xt. Okay. We have already calculated g of x, v of x. Now we can write the solution for u of xt. Okay. By putting the value of v of x comma t and g of x, we can write the solution for u of x comma t. Just wait. The solution for v of x comma t is an sine n pi L x e की power minus and what is g of x? U2 minus u1 upon L into x plus u1. So this is solution for ux comma t. The question say find the temperature in the bar after long time. Long time means that is okay. When t tends to infinity, the first term will become 0. What will be the remaining terms u2 minus u1 upon L into x plus u1. So this is the temperature in the bar after a long time. Is there any doubt in this question? Is it okay? Okay, just recall the question number 3 and the question says suppose a thin box has temperature u1 at x is equals to 0 and u2 at x is equals to L. Find the temperature in the box after a long time. So the given problem can be represented, okay, x is from 0 to L and at one end the value of 0 comma t is u1 and L comma t is u2. So to solve this type of inhomogeneous problem, because the boundary condition is not homogeneous type, so we have to formulate the solution is of the type vx comma t plus some g of x. Now we have to calculate g of x t separately and v of x comma t. G of x comma t we can write in the homogeneous form, and g of x by using this above equation 2 we can find g of x. Okay, if we put from here v of t, v of x, then you will get g double dash x, this expression. Okay, and by this condition you will get these boundary condition. Fine, and the solution for g of xt will become this. And after applying boundary condition you will get g of x. Now you can write the solution for system 2 again by variable separable method. You can write the solution for vx comma t. Okay, after writing vx comma t we can write ux comma t, and the question says temperature in the bar after a long time, that means t tends to infinity. Okay, so we can get the solution. Now let's move to the next question. Okay, question number 4. Okay, let's use. Now this question, first of all you will try to solve, and after that we will discuss. Find the temperature. The question say find the temperature in a bar of length 2 whose ends are kept at 0 and lateral surface insulated when the initial temperature is pi x upon 2. Please formulate the problem and tell me the heat equation with initial condition and boundary condition. Please write the problem first of all. How to model the problem?
ut minus x6 equals
Yes,
where 0 less x less 2 and t greater than 0.
yes. What will be the boundary condition?
And the boundary u0t equals 0 and u2t equals 0 for all t greater than 0.
Okay, what will be the initial condition?
And initial each x ux0 equals sin n pi by 2 plus 3 sin pi x
Yes,
by 2.
okay. Because x is from 0 to 2, because length is 2. Boundary condition will be both ends are kept at 0. Okay, so 0 comma t will 0, 2 comma t is will 0. Initial condition is given. This is pi x. Can anyone tell me the solution for this problem? Without using initial condition, what will be the solution? Because the use of initial condition is to find the coefficient value an. Okay, But before we can write the initial condition for heat equation, solution for the heat equation. What will be sine or cos?
Sine, ma'am.
Okay, because in the boundary condition they are insulate not they are free ends, not insulated ends. So sine will be there. And pi by L is 2 whole square c square into t. So this is the solution. Now by using initial condition we have to calculate An. What is initial condition? Initial condition is given sine pi x upon 2 plus 3 sine 5 pi x upon 2. So this is initial condition. When we put t is equals to 0 in the solution, then right hand side sine pi x upon 2 plus 3, because ux0 is given, is equals to, by putting t is equals to 0, the right hand side will become an sine so can anyone tell me what the value of an from here?
Ma'am, A1 equals 1
Yes,
and and A5 equals 3
and rest of the an will be 0. Okay, so by comparing both sides, an 0 for all n not equals to 1 not equals to 5, and for a1 when you put n is equals to 1, the coefficient of this is 1, so a1 will is 1, and when you put n is equals to 5, you will get a5. The coefficient of sine 5 pi x upon 2 is 3. Fine. So we can write the solution. Pi x upon L is 2. For a5, where x is 0 to 2 and t greater than 0. So this is required solution. Is there any doubt in this question? Clear? Okay. So let's move to the next question, question number 5. So this will be the last question. So please try to solve. Question number 5. I'm going to write the question. So please note down the problem from here. I'm not going to write the problem. Answer is also given. Find the temperature Ux, T in a homogeneous bar of heat conducting material of length L. This length is given, x is from 0 to L, with ends kept at 0 temperature. And the initial condition is given, alpha x L minus x upon L square. So you have to formulate diffusive constant of the bar is C square. Okay. Please formulate the problem first of all in the similar manner as we have done in question 4, 3 and so on. Formulate and try to solve. The answer is given. Otherwise, I will solve for. Are you getting the answer? Are you trying? Okay, let me solve. Okay, okay. Okay, I'm just writing the model formulated as the given problem modeled as, I'm just writing the model. Diffusive coefficient is given c square, diffusive constant, sorry. X is given from x 0 to L, t is greater than 0. And initial condition are given as, sorry, this is not initial condition. The initial condition is alpha x L minus x upon L square, and the boundary condition now the solution. Tell me the solution. Before using the initial condition, what will be the solution? Again, we will apply variable separable. We will set for SL problem, and by using x, the eigenvalues of x, we will find the solution for t, and we can write the solution. Let's say this is 1, and this is 2, this is 3. Satisfying 1 and 3 is of the form sign will be there because there is no insulated end. Now please apply initial condition and tell me the value of an. Is anyone getting the answer?
n is 4 alpha by n cube by a cube.
Okay, let me show the answer. You can match the answer. Are you getting the same expression? This is the answer.
Yes, ma'am.
Okay, good. Okay, uh, let me complete the solution. By initial condition, which is given in equation 2, t is equals to 0, then an sine n pi x upon L, this will become 1 after putting n t is equals to 0. Alpha x L minus x upon L square. Fine. Where x is from 0 to L and t greater than 0. So what will be the value of an? The integration of into and the integration of denominator means 0 to L sine square and pi L upon x. The integration of denominator will be 2 by L, and for numerator you will use integrating by parts. So this is first, this is second function. So we can write alpha and L square outside. 2 alpha, so this will become 2 alpha L cube. So the expression left, and the integration of sine will be cos n pi upon L x upon minus n pi by L, and limit is from 0 to L, and the differentiation for first term will be L minus 2x. Again the integration of cos sine n pi by 2. This is 2, not this is L. L is given, and the limit is from 0 to L. Again the differentiation for first term will minus 2, and again integration minus minus will become plus here, and the limit is from 0 to L again. Now we are going to put the limit. If we put the upper limit, the first expression will become 0. You will put lower limit, the first expression will also become 0. Fine. And sine, here x is also there. Sine n pi will become 0, sine 0 is 0. So only the term we will left with the third term. So after putting the upper limit, the third term will become, so this is the multiplication with 2 alpha upon L cube. Minus 2 cos of n pi L upon L upon n pi upon L का whole cube minus cos 0 will become 1 upon n pi upon L का whole cube. Fine. 2 we can take it outside, 4 alpha upon L cube. Okay. This will become plus L cube upon n cube pi cube. We can take it outside, so 1 minus the value of cos n pi is minus 1 की power n. So we will left with this expression. Fine. So this will cancel out. If n is even, then en become 0. Okay. So the required solution, en is 4 alpha. When n is odd, this will become 2. Fine. Pi square, n is, we can write 2n minus 1 for odd terms. So no, we can write n is from 1 to 3. And at the place of n, we will replace it 2n minus 1 into c square. This is in the power into t. Okay, let me write. Sin n pi x upon L, at the place of n, we are replacing 2n minus 1 because n is odd, This is C. So this is the required solution for question 5. Is there any doubt in this question? You can ask if there is any doubt. You can ask if there is any doubt in question 1, 2, 3, 4, 5. I can repeat any one of them. From which book we will get these kind of problems? Uh, the writer of the book, I think. Have you heard about the name Tin Mint? You can follow the book of Tin Mint for the partial differential equation. Okay, I'm writing the. Okay. Uh, you can follow this book. Otherwise, I will suggest another one. I'm not able to recall the name of the book. I will I will suggest in the next session or on the WhatsApp. Is there any doubt in this session? Okay. So that is all for today's session. Thank you for your cooperation.